Hello, this is Mr. Stansbury. I'm going to take you through the notes on shrinking, stretching, and reflecting parabolas. At the end of this, you should be able to say, I can describe the transformations of f of x equals x squared, and I can write the equation of a function given a transformation of f of x equals x squared. Okay, so first off, let's look at the general formula here. We've got f of x equals a times b x minus c squared plus d. It's a bunch of mumbo jumbo stuff right now. Let's show you what each one of those things stand for. Here's the two things we've talked about earlier in the last section. This c here is the horizontal translation. The d is the vertical translation. And then we have these a's and b's. Okay. Where you are not going to hardly ever see any of this B stuff here. So I'm actually just for you for right now, let's just not even sweat this B stuff. I'm going to leave it up here. I wanted to at least show you that, but really we're going to just deal with the A's. We're not going to deal with the B's just yet. But just so you know, the B, this does affect the horizontal stretching and shrinking. So horizontal meaning left to right stretching and shrinking. We're not going to deal with that just yet, but just so you know that it is there. No need to write that down. What you need to worry about more, not worry about, but understand is the A. And the A, I tend to think of this as it's really the slope. It's not the slope, but it's the slope to the next point from the vertex, only to the next point. It doesn't work for any past that, but basically if a is greater than 0, it opens up. If a is less than 0, it opens down. And if the absolute value of a is greater than 1, so like negative 1.5, 1.5, stuff like that, it's vertically getting stretched. And if absolute value of a is less than 1, 0.5, negative 0.5, those are vertically shrinking. Okay, so I think the best way to take a look at this and to understand this better is to look at some examples. So let's do that. Okay, so describe any vertical translation, horizontal translation, vertical stretching or shrinking, horizontal stretching or shrinking, and then sketch a graph of these things here. All right. Okay, so I copied down the important stuff from our previous screen, which is right here. We don't need that anymore. I left the B part off because, again, we're not going to deal with that just yet. Okay, so on these here, describe vertical translation, horizontal translation, vertical stretching or shrinking, horizontal stretching or shrinking. We're going to get rid of that and then sketch a graph. But really what we should put in place of that is reflect, if it reflects over x-axis or not. Okay, so let's go back to what we know from the last section. So this means this negative 4 means it's going to go down 4. This positive 2, we think of what do we put in for the x so that we get 0, and that's negative 2. So x is going to equal negative 2, so that means we're going to go to the left 2 and down 4. So here's our original. So we're going to go to left 2, down 4, and there's our vertex. Okay, so this is the vertex, right? And then now, here's what I like to think of. This negative 3, this is why on before here I put that. Let's see if we can get this in here. Nope, that's the wrong one. Remember we called that the slope. Okay, so really what's happening is you take this negative 3, put it over 1, and to get from this point to the next point, we go down 3 over 1, and we reflect that the other way as well. We go down 3 to the left 1 as well. And that gives us 3 nice points for our graph. Okay. Now, what it's asking for up here is we have to describe all these things here first. I was just kind of plotting some points. In fact, we're just going to even sketch our graph here just to kind of give us an idea. Okay, and really we only have 3 points. You normally want to have 5 points. We'll get back to that here in a second. But let's go back and describe this. So vertical translation, there's our vertical translation, down 4. Horizontal translation, we went to the left 2. So we got both of those taken care of. Vertical, stretching, or shrinking. So it is going to stretch by a factor of 3. And since it's negative, it does get reflect over x-axis. So normally, axis. Normally this would go up 3 over 1, up 3 over 1 the other way. It normally opens up, but since it's negative, it now opens down. So it actually, instead of, again, going up, we reflect it over this x-axis, and it actually now goes down instead. Okay? But again, probably the easiest way to do that is think of this negative 3 as negative 3 over 1. From the vertex, go down 3 over 1, down 3 over 1 the other way, and that gives you your general shape of the graph there. Okay? Normally we want to have 5 points. This gives us 3 for sure. So here's what I would do to come up with the next points. I know that this is at negative 2, negative 2, negative 1. I'm going to plug in 0 because that will give me a point. So for my x and my y, I'm going to plug in 0, and I'm also going to plug in, let's say I plugged in negative 2, negative 3. I'm also going to plug in negative 4. That's going to be the next one over on that side. And here's a nice part with this parabola. Once I figure out what one of these is, the other is going to be the exact same because it's reflecting, the parabola is a mirror image of itself. So let's plug in 0, see what we get. So we go negative 3 times 0 plus 2 squared minus 4. So we get negative 3. 0 plus 2 is 2 squared minus 4. So that's negative 3 times 4 minus 4. So negative 12 and negative 4 gives us negative 16. Okay, so we don't have enough space. Negative 16 is going to be down here somewhere. And then just like these other ones here, if this one is at negative 1, 2, let's see, 5, 6, 7, negative 7. This one's also going to be at negative 7. So this one's at 0. This negative 4 is also, 0 is at negative 16. So the negative 4 is also going to be at negative 16. So officially it's what? Negative 4, negative 16. And this is at 0, negative 16. Those are the coordinates of the points. And then so then you could continue that graph down through those points. Okay? Okay, let's do we do this one, and then we've got a quick one last example after that, but let's take a quick comedy break. I just really want to know how in the world those goats got up in the tree like that. That's crazy. Anyway, this one here, if you'll notice, look at this. We've got this business going on in here, 2x minus 6 squared plus 1. So I'm actually going to change this one here a little bit because we said we weren't going to deal with the numbers inside the parentheses yet. So I'm going to change that really quick. Okay, this one looks a little better. We'll deal with the horizontal stretching and shrinking later on. But for now, we've got this one here. So this says this plus 1 means it gets translated up 1. 6 minus 6 gives us 0, so it's going to go to the right 6. And then it gets stretched by a factor of 1/2. So it actually gets squished. Okay, so stretch by 1/2, which basically just means it gets squished by a factor of 2. So again, we'll just use this as our little slope business here. Okay, so we're supposed to start here at 0, 0, but now we're shifting up 1 and to the right 6. So here's our new vertex. Now with a fraction or a decimal, Still do the same thing, still put it over 1. Even though it's already a fraction, we're going to think of it as 1/2 over 1. So to the next point, we're going to actually go up 1/2 over 1, and then up 1/2 over 1 the other way. And that's going to be what our generally what the graph's going to look like there. Okay, and then so we want to come up with a couple more points, right? We want to come up with our x and our y. Let's see, we want to do what, 4 for x, and then also 4, that's 5, 6, 7, 8 for x as well, and come up with what our y's are going to be. Again, once we find one of them, it will be the same for the other one, so we really only have to do this once. So we're going to do 1/2 of 4 minus 6 squared plus 1. 4 minus 6 is -2 squared plus 1. -2 squared is 4, plus 1/2 of 4 is 2, plus 1 gives us that these are both going to be 3. So we're going to go at 4 is going to be up at 3, and so is 8 is also going to be up at 3. So then here's what our graph looks like. Okay. One last quick one here. Okay, so example, write the equation of a parabola with the transformations. So we're just going to do one of these. We're going to go left 3, up 6, vertical stretch of 2, reflects over the x-axis. So we have f of x or y equals, right? And we've got possibly some number in front there. And we've got our x here, and we've got our vertical translation here. I usually like to try to start from the right and kind of work back to the left. You do it however you want, but I know that this thing goes up 6, so that means that's going to be plus 6. Now it's going to go to the left 3, which means that the x is -3. So -3 and what? There's supposed to be a squared there. -3 and what gives us 0? Plus 3. Okay, so this left 3, that's where this is coming from. Now we got a vertical stretch of 2. That's the number that goes in front here, right? Because we're stretching by a factor of 2. And then it reflects over the x-axis. So since it does that, we get a negative here. So it reflects over the x-axis. There's where our negative is from. And then this 2 is that one right there. Okay? All right. That's all we have for shrinking, stretching, and reflecting parabolas. If you have any further questions, please feel free to ask in class. Thanks.